Imagine for a second that the most profitable AI breakthroughs of the next decade have absolutely nothing to do with, you talking to a computer.
Right, no prompts.
Exactly, no prompts. No friendly robotic voices. On this deep dive, our mission is to unpack exactly that. We are looking at the research detailing the invisible backbone of AI infrastructure, these sort of hidden hubs that are quietly being built to dominate the 2030s.
Yeah, it is a massive shift.
Okay, let's unpack this. Think of today's chatbots as just a shiny light bulb.
It's cool, and we all stare at it.
Right. But today, we are looking at the massive invisible power grid being built underneath to actually keep it lit.
Yeah, that is a really crucial distinction. I mean, the conversational interface era, that novelty phase we have been in, is reaching saturation.
It really is.
And the real wealth, at least according to the materials we are looking at today, is in the utility phase. That is where intelligence stops being a surface-level parlor trick and becomes, well, as ubiquitous and invisible as electricity.
But you cannot build a revolutionary global power grid if only a handful of big tech companies own all the generators, right? I mean, right now, it feels like everything is trapped in a few massive server farms.
Exactly. And that bottleneck, like big tech hoarding GPUs, is exactly what is shifting right now. The sources point to this rapid move away from centralized data center.
Okay, toward what?
Toward hyperlocal sovereign compute clusters. Basically, developers are bypassing the big servers entirely through peer-to-peer hardware orchestration.
Wait, slow down. Peer-to-peer. Are you saying this is the AI equivalent of BitTorrent?
Yes, essentially.
Like using a network of regular computers to share raw processing power instead of, movie file.
The concept is very similar, yeah. But the mechanics are, well, much more complex. Because to make that work without massive lag, you need incredibly efficient hardware-software handshake protocols.
Handshake protocols? That sound like some heavy IT jargon.
Fair enough.
How does that actually solve the lag of using scattered computers?
So think of these protocols as a hyper-fast traffic cop. They take a massive AI computation, say, analyzing a new drug molecule, and shatter it into millions of tiny encrypted puzzle pieces.
Oh, wow.
Right? And then the network sends those pieces to idle graphics cards all over the world, solves them locally, and instantly stitches the answers back together.
That is wild.
It completely dismantles the old cloud monopoly.
Okay, I am tracking the decentralized processing power. But if this massive brain is scattered all over the place, how on earth does it store and remember anything?
That is the big question.
Right, like if it is fragmented, how does it instantly retrieve complex information?
Well, that is where traditional databases just completely fail because they are way too rigid. The solution outlined in the research is a shift to high-dimensional latent space indexing.
High-dimensional latent space indexing. Okay, you lost me.
I know, it is a mouthful.
It sounds like something straight out of Star Trek. What does that actually look like in practice?
Let us put it this way. A traditional database is like a slow alphabetical filing cabinet.
Yeah.
If you want to file on dogs, you look under D. But latent space indexing gives the AI a sort of spatial memory. It plots concepts on a multidimensional map based on their relationships.
So they are grouped by meaning.
Exactly. Dog is mapped near puppy, leash, and bark.
Oh, so it does not need to search alphabetically. It instantly grabs complex concepts because they are literally clustered together in this web of ideas.
Precisely. And for AI to act as a true global utility, it needs these specialized spatial memory layers. That is how it maintains context across trillions of data points or tokens.
Trillions?
Yeah, trillions. It allows the AI to autonomously move complex concepts between different network agents at high speed without ever losing the thread of the thought.
All right, but let us ground this in reality for a second. If my neighbor's gaming PC or some scattered network is suddenly part of this giant AI brain operating the physical world, how do we know someone hasn't tampered with the data it is processing?
Yeah, security becomes the existential threat here, and the infrastructure is adapting in two main ways. First, we are moving past general-purpose chips.
What do you mean by that?
Well, the 2030s will see hyper-specific hardware built for exact industries, like chips optimized exclusively for molecular biology or for real-time kinetic robotics on a factory floor.
So, incredibly narrow-focused brains.
Right. But the second part answers your security question directly. It is the zero-trust intelligence security layer.
Zero trust. Sounds intense.
That has to be. Future AI models are going to be trained primarily on synthetic data, which is data generated by other AI.
Wait, so AI training AI?
Exactly. Because there is no human in the loop checking that data, we have to rely on cryptographic verification.
Like a digital wax seal on every single computational thought. But how does that actually prevent the whole system from crashing?
Because in a network where thousands of autonomous microservices are trading logic back and forth at light speed, one piece of poisoned data could cascade. It could corrupt the whole grid.
So the wax seal prevents that.
Yes. The cryptographic seal mathematically guarantees that every piece of data and the logic that produced it has not been altered. Verifiable compute is really the only thing preventing systemic collapse.
Wow. So for you listening, here is the real takeaway. The future is not about writing better prompts.
Not at all.
It is about this invisible plumbing, the peer-to-peer compute, the spatial memory of latent space, the zero-trust cryptography. That is what is turning raw intelligence into an unstoppable utility.
It really is the foundation for the next decade of innovation. We are basically building the roads for a completely new kind of traffic.
But it does leave you with a wild thought to ponder.
Oh, absolutely.
As these models increasingly train on synthetic data, constantly protected by zero-trust cryptography, how long until an AI begins encrypting and sharing verifiable logic that humans can no longer even comprehend?
That is the million-dollar question.
We might just be staring at that shiny light bulb completely blind to the alien intelligence surging through the power grid.